Hi hola bonjour privet salam. The following model is that of a jet engine, along with its sub-assemblies such as variable diffuser, 2 stages of compression, 1 stage of turbine, combustion chamber, main axis shaft, 6 fuel injectors, intake fan, turbine housing. Firstly, the variable nozzle consists of levers and blades that work in conjunction to vary the nozzle geometry. Rivets are used to join overlapping blades, as nuts and bolts can't be used in this high-temperature region. Secondly, there are structural blades that are mounted on the shaft, which are utilized to hold the housing. Therefore, the housing does not collide with the rotating parts. These structural blades are stationary and hence are designated a secondary purpose, which is to redirect airflow onto the rotating blades, which enhances the turbine's efficiency. This is called the stator part of the turbine. These in turn make up a total of 3 structural components, 2 in the compression region and 1 in the combustion region. Shout out to Cadd Science for this amazing build. Link in description for his channel in case anyone wants to build this exact model. The full step-by-step guide is present on his channel. Thirdly, the stages of compression or turbine are mounted on their own shafts, which are consequently mounted on the main shaft of the engine. This allows the different stages of the turbine or compressor to spool independently from each other, further improving the performance and efficiency of the engine. The compressor type used in this case is an axial compressor. Furthermore, as the compressor stage progresses, the diameter of the central mounting of each set of blades increases, while the height of the blades decreases, effectively increasing compression as the stage progresses. Similarly, the turbine stage follows the same design philosophy as the compressor. The second stage compression has blades in the opposite direction to the first stage that allows a more aggressive compression profile. The combustion chamber is designed in a particular shape to assist the thermodynamic as well fluid dynamics of the fluids passing through the chamber. Since all the components are mounted on the same shaft, the turbine rotates the compressor stages, which compress more, which in turn makes more power, thereby establishing a self-feeding loop that can only be controlled by fuel injection and air bypass. The air bypass is increased and fuel injection reduced for low-speed operation and vice versa. Lastly, ISO standard nuts and bolts are used for the entire assembly. Aerospike is installed at the trailing end of the engine, which also improves engine efficiency and flow separation.